Hello everyone, in this question we will try to find out the I1, supply voltage, I2 and the supply current. So let's try to find out the current through the first branch, which is I1, and the voltage across this battery. So finding the I1 is pretty straightforward. If you put the V equal to IR, and you can easily get the I1, where your voltage across this 9 ohm resistor is given, which is 27, and the resistance also we know, which is 9 ohms. So according to the Ohm's law, we can write the equation as I1 should be equal to V1 over R1, where V1 is 27 and R is 9. Then you will know the current I1 is equal to 3 A. Keep it in mind, the same 3 ampere current is going through this 15 ohm resistor as well. And another thing that we need to find is the voltage across this battery. So if you put the KVL across this loop, then we can write it as V, because the voltage direction across this voltage and the loop direction both are in the same way. So that is plus V. Then the voltage direction and the current loop direction is in the opposite direction for voltage across R1, so it will be minus V1. Same as that one for the V2, loop direction is downwards and the voltage direction is upwards, so again it's in the opposite direction, so it's minus V2 should be equal to 0. So according to the mathematics, if you rearrange the equation, you will end up like V is equal to V1 plus V2. So according to this equation, V is equal to V1 plus V2. V1 that we already know, which is 27 volts, but V2 we had to find out. If we found out the V2, we can easily find the supply voltage. So how do you find out the V2? Finding V2 also pretty straightforward. If you apply the Ohm's law across this 15 ohm resistor, we will straight away get that one, right? So according to the Ohm's law, V2 should be equal to I1, because the same current is going through this 9 ohm resistor and 15 ohm resistor, so that is 3 ampere into R2 is 15 ohms. If you multiply both, then you will get 45, and we know that V is equal to V1 plus V2, since we know the V1, which is 27 volts, that is given in the question itself, and V2 that we now just found out, which is 45. If we add them up, we will get the 72 as a supply voltage. Let's find out the I2. So to find out the I2, if you apply the V equal to IR, you can rewrite this equation as IA will be equal to V over R, voltage divided by resistance. So let's figure out the V3 now. So if you look at the R3 resistor, which is parallel to this R1 and R2 resistor combined. So we can say that whatever the voltage across these two resistors, that should be equal to V3. So in the question itself, we know that V1 is 27, and the previous slide we have seen that V2 is 45 volts, which means the voltage across these two resistors, that is equal to 72 volts. Since it's parallel, these R1 resistor and R2 resistors are parallel to this R3 resistor, we can directly say that this is also 72 volts. So if you apply this Ohm's law across this R3 resistor, and to find the current, which is I2, we can straight away say that I2 will be equal to V3, the voltage across this resistor, which is 72, divided by the resistance 8 ohms, which is, you will get 9 amperes. So if you found out the total current I, which is a source current also, then according to the KCL at this node, I can say that the I current is coming and splitting into I1 and I2. So adding I1 plus I2 will be definitely should be equal to your source current. So according to that equation, we all know that V1 is already in the previous slide we have seen that it's 3 amperes, and V2 we just now find out which is 9 amperes. If you add them up, then according to the KCL you will get the supply current as 12 amperes. Thank you for watching. Until next time, keep learning.